let's see if this works. Threat hunting through JavaScript at internet scale. My name is Alexey. I have this little thing here, so I'm just trying to understand where I'm looking at. But anyway, so my name is Alexey. I am CTO and co-founder of a cybersecurity startup called Clean.io. It protects hundreds of billions of page views per month from JavaScript threats, including sites like CNN and properties like Hearst that own things like Cosmopolitan and things like those, as well as various advertising networks, e-commerce properties, and so on. I've also been a developer, a project manager, and a pen test lead, and other things in a company called Sigma.software. And most recently, I moved to the US in 2015 and lived there ever since. I am originally from Ukraine, and yeah, here I am representing two companies, the cybersecurity startup and a software development company with about 2,000 employees, and hopefully in next year we're opening a presence here in Brazil as well with Sigma Software, so hola. Anyway, our subject is threat hunting, so I thought we first could break down these two words, right? And we'll probably start with the threats. So what are the threats in JavaScript, right? And I think the answer to this depends on the context of what we're talking about, as well as on the threat model. So let's take a little bit into context first. So here we see a browser. Hopefully you can see this. And here's a quick question. Do you guys write all JavaScript that executes on your site? Well, all right. I guess here's a different question. Do you even read the JavaScript that executes on your site? All the different things that you load and things like those, right? So I think the way that developers often see their web applications is this. Like, there is a piece of script that they wrote on their own that is executing in the user's browser. And there's probably also some third-party scripts that they loaded, and some frameworks that they used, and probably or potentially some ads, depending on the site that they're developing and things like those. And in reality, there is lots of JavaScripts that are executing within the context of the end-user browser, within the context of your web application, whether you realize it or not. In addition to the things you do realize, there's probably also other things. Something injects a video widget. You probably forgot about the analytics script you put in there, or product manager put in there a while ago. There's probably also a browser extension that is injecting a content script onto your site that may affect it in a different ways. And some ISPs, internet service providers, also inject JavaScripts into the pages, and even local malware installed on the end user device can be injecting some JavaScript. So there's lots of things going on in your web application, right? And the user, however, while this is the reality of what happens, the user will see, like, I'm on this website, I just bought, you know, I'm on this, let's say, ticket sales website. I'm typing in, I'm buying a ticket. Everything on this website is the website owner that they wrote it. That's how they typically view it. They wouldn't know that this is a myriad of different parties that are involved in there. And whenever they type in something into the site, the assumption of the end user, I go and buy something, I think it's, I'm typing it so that the author can see it, so that whoever owns the site can see it, right? Or the user could say, whatever I see on this website is what the author intended that I would see. So if the site shows me something, it's probably coming from whoever created the site, right? But in reality, going back to this question, we probably don't even control the JavaScripts that are executing on our site, let alone read or write. And in some cases, we might not even know, right? Do we know for all the JavaScript to execute? We absolutely don't know, right? So, okay, so this is our context, right? The context is the user trusts the site where they're running, and at the same time, we've put in a lot of code that we've never seen or even know about that executes inside of this trusted environment. So that already doesn't sound like super amazing, right? But then there is this other part, the threat model part of this, right? And so what's going on with the threat model? And how big of a deal is this really? Because we're running JavaScript, and it's not like we're running it outside of the browser, right? We're running it inside of the page, so what could go wrong? But by the way, before we switch to the next thing, what would you do if you would be running an executable file outside of the browser, right? You would probably run it in a VM just to make sure, because you don't know what this code is, right? Or maybe you create a Docker container or something like this and run it there. Or maybe you would, check its signature and confirm it's from the valid author that you trust. Or maybe you would scan it for malware by using your favorite antivirus program or uploading it to a site like virustotal.com. Or maybe the best of all is you could avoid running it because somebody sent you this unknown file, and why would you even run it? But sometimes, or some people might just hope for the best, and turns out that this is exactly what happens in browsers. People just put the code that they have no idea even executes on those sites. They don't know what this code does, what it is. They put it in their trusted environments, and they just run it inside of the user's trusted environment and hope for the best, right? So, so going back to our threat model and trying to understand what actually could happen if this JavaScript decides to do something bad. And let's see what could happen if this even works. I think my clicker is no longer working. That's probably JavaScript as well. Let's see what happens. There we go. You can go on a site and some ad shows up and says you want an iPhone, or you can win it by clicking this link, or a totally innocuous multiplication Bitcoin wallet that's magical, and see this, or all these alerts. We've all seen them every now and then. This is JavaScript that executes on the site, coming from somewhere and displaying fake UI. Here's another example. You're typing in something into a form. We've all seen this form, right? That comes from Stripe. And normally, when we see the ad next to it, we don't kind of think that this ad has access to the stuff that we type into this form. But in fact, it may very well have access to this, and steal that data. So just some of the attacker's goals or capabilities that they have that could contribute to the threat model or form the threat model could include things like showing fake UIs or phishing or creating a browser locker, like your browser is no longer available for you, and locking its functionality, or showing some various virus alerts, or exfiltrating your data that you typed into the site, or altering the functions, or even committing fraud on your behalf, or fingerprinting you, forcing downloads, whatnot. Anyway, so it's kind of a big deal, right? That lots of things can happen that are bad in JavaScript, and yet we don't really know what's going on with this JavaScript. We don't control it. We can tell it not to do something, right? This is the threat model and where we are. So we now understand that we have this trusted environment context, which we're already kind of by default violating by loading some JavaScripts from third parties that we don't control, and that attackers have goals that we've seen before, and they also have capabilities to achieve those goals. And lots of times the way that this is treated on the internet is just hoping for the best. So that is about the threat part of the threat hunting, right? But before we switch to hunting, I wanted to talk a little bit about mitigation. So what do people do to mitigate those threats, right? And so I opened the site, BrazilianTimes.com, which I've never seen before, and it loaded 42 scripts. So one of the things that people could do is just, let's say we're going to audit and check all scripts that are running on my site. But there's lots of scripts, right? So it's not really a very easy option for everybody to follow, and also those scripts are probably changing all the time. So some people would say, why don't we scan the scripts first? Maybe we create a tool that scans them and understands if they're doing something bad, and we scan it. And in this case, we'll have stuff that is doing good stuff before scanning, and then once we've scanned it, can switch to doing something bad. This is the problem known as time of check, time of use problem, where during the check, everything is fine, but after the check, it may not be so fine. So the other mitigations that they have that are beyond scanning and beyond just auditing stuff manually include things like content security policy. It's a built-in browser feature which is defined on the left. You can see the W3 definition of this as a tool which developers can use to lock down their applications in various ways, mitigating the risk of content injection vulnerabilities, right? And it's a good policy. It's a good feature. It works. It's well supported across all the modern browsers. It is reasonably difficult to bypass. If you search for bugs in Chrome, you'll see 222 bypasses, which is, knowing how big Chrome is not too many, but and it's continuously being fixed. But the problem with this is it's an all or nothing solution, because what you have to do with content security policy as a developer, if you're familiar with it, what you have to do is create this HTTP header that will go and say, I only allow running scripts from google.com or cloudflare.com or whatever else.com. So you have to create a sort of an allow list that has those scripts running, or you have to review every individual script and create a nonce or a hash of that script, and then allow those scripts individually. So it's pretty hard to run various scripts that you don't necessarily know about, especially things like advertisements or other things. You have to only whitelist specific things that you'd like to allow to run. And it's pretty hard to maintain. Now, it is actually somewhat changing. You see a little asterisk in here because there's also this new directive called script dynamic inside of content security policy that allows people to create one script that loads everything else. But then it's kind of it creates an easy opportunity to bypass things. So there is no clear-cut answer here. And it's not applicable to many cases of third-party JavaScript. So what else do we have in the browsers? One of them is the thing called sub-resource integrity. So we load these scripts that are called sub-resources, and it works pretty well. But again, you have to create a hash of the script that you're going to load. And then whenever the third party changes the script, let's say you load jQuery and you need to update its version from a CDN, or you load some library that you have to update, you have to maintain those hashes. And there are tools for this that will automatically create hashes and integrate this into this. But taking a look, having reviewed studies, people rarely utilize this. From 1 billion sites, only a few million implement CSP. And most of them implement them incorrectly, according to the Google study, Google research that they published. So it is also really hard to maintain. And it's an all or nothing solution. You can either run all JavaScripts if you don't use it, or really only a few JavaScripts, and it's hard to maintain. So the other approach that people could use is say, you know what, we're not going to allow a specific list of JavaScripts. We're not going to just say, only run these 3 JavaScripts. Instead, what we're going to do is we're going to say, run any kind of JavaScript, but we'll isolate it from the main execution context into a separate origin using the same origin policy. And it works okay in many browsers, and we actually helped to implement some of those things in Firefox and make a couple other fixes about this. But you can't just move all the third-party JavaScript into a third-party origin oftentimes. And therefore, it is almost, again, all-or-nothing solution. Even though it is more granular, you can allow certain features but restrict certain other features from JavaScript, it is still almost like an all-or-nothing kind of solution. Well, one could say, you know what, I don't worry about the JavaScript execution part. Let's just let it execute. What I'm going to do is I'm going to just use pop-up blockers or other content blockers and just mitigate the effects of this. But pop-up blockers are only one issue that can be, pop-ups are only one issue that can be caused by third-party JavaScript. They're also often disabled. In fact, if you can see the screenshot, which I'm not sure you can, but if you Google pop-up blocker, the first, or the actual 7 links or whatever on this page are how to disable pop-up blocker. They're not how to enable it and use it as a security feature. So it's not really the best way to rely on this. It's kind of a hope for the best option. So, oh no, there we go. Here's a little spoiler for you. Anyway, so we have the solutions on these scale. On the left side is impossible to maintain, so it's very hard to maintain in practice. They sound good, but it's hard to maintain. On the right side, those are easy to maintain. The things that will just set it and forget it. And then on the bottom, there are things that are easy to bypass, and on the top are difficult to bypass, right? So what we want is something that is probably easy to maintain and difficult to bypass for the attacker. But let's see how these features that we talked about pair out. So content security policy is somewhat difficult to bypass, as we discussed, but quite difficult to maintain, right? Because you have to define exactly which scripts you're going to run. And if we look at sub-resource integrity, it's even harder to maintain because CSP has lots of options and sub-resource integrity has only a few options. And it is more difficult to bypass, but it's very hard to maintain. So same origin policy, on the other hand, is quite a bit easier to implement, not super easy, because you still have to isolate all the scripts into a different origin. It's not always possible. But it is also easier to bypass, and there are lots of bypasses for it, and therefore not ideal, right? So pop-up blockers, they're like not even hard to bypass at all, and you don't have to do anything to maintain them. So we're kind of left with this quadrant where we were looking for some good options that is kind of empty, right? And maybe you guys know of a better solution, but auditing the scripts and doing other things, or pre-scanning them, or utilizing these browser features, none of these are very difficult to bypass for the attackers and at the same time easy to maintain. What we want is developers. That is why the JavaScript threats that we talked about are so prevalent on the internet, right? And so we want to do this is, what we've been working on is a project that's here that attempts to analyze the JavaScript that executes in your sites, on many sites, at scale, in real time, and take actions about during the analysis that it makes, right? So what is this? What if we could analyze JavaScript in real time as it executes, right? So it's kind of a set it and forget it mode, and define the things that we would like to do in sort of a signatures approach, which you found in your antivirus solutions. This would also address the problem with time of check, time of use problem, because we don't first check and then run. We literally just run it, but in the meantime, we have like this guard that's sitting on top of the JavaScript and says like, yeah, no, you're not going to go there. right? So it fills this gap that's created by all these browser features that are all or nothing. You either allow these 3 scripts or all scripts. There is a big in between here that is not filled with anything. So it fills this gap with us. And it can discover lots of different things in the wild samples of various exploits that are written in JavaScript. And it also helps by design make the attacks unprofitable, right? Make the attacks harder to profit from, because if we execute a part of this but only block the bad part, the attacker has to still spend time on creating the payload, executing all the other things, getting into this page, but not getting the result, which makes it unprofitable. There is no 100% security in anything, but if you make it unprofitable for the attacker to try and achieve some things, then they would go to the next place where it's easier, cheaper, faster, right? So that is the goal here. And it could cover JavaScript from many injection sources, as we've seen, right? So if we go back to this page that is presumably your website, which has all of this stuff and maybe even other stuff. If we, let's take a look at this ad, for example. But any script really is the same thing. What we would do with behavioral analysis is this: when we view the ad, we will create a lightweight JavaScript virtual machine that is going to log every operation that is noteworthy inside of this action log that is associated with the execution context of this ad, right? So for example, if the ad loads the script from domain.xyz, we're like, okay, no problem. And then the ad is like, okay, I'm going to fingerprint the user and check what kind of operating system and device based on various device characteristics and WebGL characteristics it has. They're like, all right. And then I'm going to submit this data and send it over to some third party over WebSocket. We're like, all right, whatever. Let's say it's fine, maybe. Or maybe already at this point it's not fine, because our threat model could say we don't want the third-party scripts to fingerprint the users and send this data to unknown sources or unknown destinations. But then this unknown destination sends back some code and says, you know what, just execute this part. And that's where, if it was a file.exe, we would say, like, you know what, we're not running it on our box. But if it's a JavaScript, we don't normally care or hope for the best. In this case, we could say, you know what, we don't want to run this. Or we could allow it to run it and then see what it does. And if it does attempt to, for example, just take the user to whatever other place on the internet where presumably it'll be scammed or something else, we could stop it at that point. So we have all these places where we could analyze, collect data points, and stop the execution. And we can also deliver rules about this using something we call TML, threat mitigation language, where we define the threat indicators and deliver mitigations on what is blocked and reported. We're going to talk about this in a bit. But this is the kind of the gist of our work around behavioral analysis, right? And so boom, now we've actually covered threat hunting. We've covered threats and threat mitigations. And now we're going to talk about hunting. What could we find with this, right? With this threat mitigation language and with VM and with behavioral analysis? We could find things like browser vulnerabilities that are being exploited on various sites. Maybe site was compromised, an additional script was added, and it was trying to exploit the users somehow. We could find it using analysis like this. We could find various exploits. We could find various fraud of ad fraud and other things. Maybe somebody firing like 1,000 pixels saying I've just viewed 1,000 ads even though I haven't viewed any ads. And things like those. We have found people, in fact, targeting cell operators in Argentina most recently that were trying to get their accounts that JavaScript was executing to get their telecom accounts and have them send the money using an XSS vulnerability on the telecom operator's website. So lots of stuff going on. And to be able to design this, what we do is we use this tool we call TML, or Threat Mitigation Language. So what is Threat Mitigation Language? It is built on top of multiple things. First of all, it needs to know the context where we're executing. Let's say it's a top-level page context, or maybe you've isolated it to a certain origin, and we're executing in this origin. Or maybe it's a small ad that the script comes from this ad. And then it creates those, or it allows to define those context-aware indicators of compromise, or context-aware indicators, where we would say things like, if this happens after this already happened, and also this other thing is in here, then we might want to do something, right? So it's context-aware. It's not one thing if somebody's fingerprinting you using this technology, but if somebody is fingerprinting you and also sending the result somewhere, and also receiving the result, and also evaluating it, or also attempting to redirect you, that's a lot of data points that we can have, and we can make decisions about whether we want to allow this or stop this from happening. And those decisions are in the form of mitigations. What do we want to do about those things, though, when we uncover those things, right? And what happens is we execute this live using a lightweight virtual machine that's implemented in JavaScript inside of, the page, right? And we protect hundreds of billions of pages. So this opens a pretty good opportunity for people to really analyze and discover behaviors online, right? And here's a terrible slide, which you probably can't see. I can't even see it on the screen. So basically, for example, if we wanted to hunt for ads stealing data from your page, what we would do is say that we define the context, the indicator, and the mitigation, right? So the context would be top-level execution context, where you have some text boxes that you type some information. And you'll also see that the top-level execution will be the context, but it needs to have initially arrived from that ad. So the ad was delivering the JavaScript that then broke out to the top and then was trying to execute something. That's the context. And then the indicator could be, let's say, the script subscribes to on-blur events. So whenever you type something into the input field and click tab or go to the next field, the on-blur event will be called, and the data will be collected from this, right? And then another indicator could be that is context-aware, that after that happened, the on-blur, it will read the values from the input and maybe submit it over XML HTTP request or fetch or WebSocket or WebRTC or whatnot. And the mitigation is we might want to stop it. Or maybe another mitigation is we just want to collect the payload. Who does it? And what is the script? And where did it come from? So we can analyze it offline. Maybe reverse engineer it, understand what it does, and do something else with it. So that's kind of our pseudo TML representation of a sort of a behavioral chain. And there is lots of examples of behavioral chains that exist out there that we could find. For example, we could find something that is, let's say fingerprinting the user and then submitting the results to a command and control server, C2 server. Or maybe, if you're familiar with the browser exploitation and binary exploitation, many types of vulnerabilities will utilize, or many types of exploits will utilize an approach where they would have to call one JavaScript function 10,000 times to be able to force a just-in-time compilation on it, and then leverage that for code execution. So maybe this behavioral trait is an indicator all on its own of something fishy going on the page, and maybe we could look for this kind of behavior. Or maybe we can discover ad fraud, which basically just sends millions of requests somewhere, right? So what we end up with this TML is kind of a private search engine, but instead of like typing in the text and looking for it in the internet, we end up with a search engine for behaviors. Who on the internet does this, followed by this, and ends up at this, right? And in this talk, we've been using it until now to discover lots of cool stuff, but it has been private to clean. So in this talk, we're kind of removing this part of private and making a first step to try and open it up, right? So before we open it up fully, what we want to do is collect feedback from you guys on what you might, find interesting to collect on the internet. So you could either email at this email address, which you probably can't see, and if you can't see it, there is a massive QR code that you can scan and just fill in this Google form. And on the Google form, you can type in things like the detailed description of what you're looking to find and why, and maybe come up with a sample of code that you'd like to find. Like, what if somebody does this, this, and this, and here's my sample of code that does this to replicate what I'd like to find. And then you could also find the context in which this is going to execute. I'm looking for this and executing on top pages or within frames or within somewhere else. And what we will do is analyze the submissions and run your telemetry collection across hundreds of billions of page views and provide you with the results for free. Until now, this opportunity is basically limited to browser vendors to a massive degree. Only browser vendors can collect who does this and this and this in JavaScript, and that's what browser telemetry is for. But public telemetry, like Firefox recently opened some additional telemetry and things like those, but public telemetry does not allow you to understand and investigate those things. But in this case, this would be way more powerful. Imagine having Google search access, but all to yourself. It's kind of cool when nobody else has access to Google search, but you do. So anyway, you can scan this QR code, complete this form if you'd like, or just learn from this presentation, never scan it, and here we go. Here's my contact information. Here's my Twitter. The Google form is above if you want to connect and discuss this further. I'm open to various ideas and just happy to discuss it anyway. And yeah, there you go. That's threat hunting through JavaScript at the internet scale. And I'd love to welcome your questions.